Now next problem is also an easy problem but a highly conceptual problem. We are given with a 2 gram sample having sodium carbonate, sodium bicarbonate and sodium sulfate. We don't know the weights of Na2CO3, NaHCO3 and Na2SO4 present in the 2 gram sample. This sample is heated to get 0.22 grams of CO2. Now in the different situation, a 1.5 grams of the same sample requires 150 ml of 1 by 10 molar HCl for complete neutralization. We need to find the percentage of each of these salts present in the given sample. Now first of all take the first sample which was 2 grams weight. This sample is heated to get CO2. Now we know that Na2SO4 does not decompose on heating, Na2CO3 does not decompose on heating, only sodium bicarbonate decomposes on heating. So the reaction will become 2NaHCO3 on heating gives Na2CO3 which does not decompose further plus H2O plus CO2. Now 44 grams of CO2 is obtained from 2 into the molecular mass of NaHCO3 is 84. So 2 into 84 is 168. So 44 grams of CO2 is obtained from 168 grams of NaHCO3. So 0.22 grams which is given of CO2 will be obtained by 168 upon 48 into 0.22 is 22 upon 100. This is 2. So this becomes 0.84 grams and hence 0.84 grams of NaHCO3 is present in the given sample of 2 grams. Hence the percentage of NaHCO3 is 0.84 divided by 100 into divided by 2 into 100 which is 84 by 100 or 84 by 2 I am sorry, which is equal to 42%. Hence we have obtained the percentage of NaHCO3 present in the given sample to be equal to 42% by using the combustion equation for NaHCO3. We haven't used the same equation for Na2SO4 and Na2CO3 because we know that Na2CO3 being a stable compound does not decompose on heating and Na2SO4 does not involve in the combustion reaction. Now we try to remember this 42% of NaHCO3 because it will help us to find out other percentages. We write this as 42% here. Now we will see the second reaction. The second reaction is an acid base neutralization reactions. So we will try to find out of these 3 which will react with our acid HCl. Now we see NaHCO3 being a base or having some basic character will react with this HCl, and Na2CO3 being a base itself or having a very good basic character also reacts with this HCl. So out of these 3 our NaHCO3 and Na2CO3 will react with HCl. Na2SO4 is a salt, it does not react with the acid involved. Hence we write the 2 reactions, Na2CO3 plus 2HCl gives NaCl or twice NaCl plus H2O plus CO2. We know that when an acid and a base reacts in a neutralization reaction, the salt is formed, water is formed and CO2 is liberated. Hence this is 106 grams, this is 2 into 36.5 which is 73 grams. Hence we can say that 73 grams of HCl is utilized by 106 grams of Na2CO3. Let us say HCl equals Y grams. So Y grams of HCl will be utilized by 106 upon 73 Y grams of our Na2CO3. Now we will write the second reaction, which is the reaction of NaHCO3 with HCl. The reaction is as follows: NaHCO3 plus HCl gives NaCl salt plus water plus CO2. Now this NaHCO3 is 84. This HCl is 36.5. So what we get is 36.5 grams of HCl is utilized by 84 grams. The 84 grams of NaHCO3 is utilizing 36.5 grams of HCl. And we know that in the 1.5 grams of our sample, what is the percentage of, or what is the amount of NaHCO3 present? Since the sample has 42% of NaHCO3, so we have the amount of NaHCO3 as 42 by 100 into 1.5, which is equal to 0.63 grams of NaHCO3 is present in the 1.5 grams of sample. So 84 grams of NaHCO3 is utilizing 36.5 grams of HCl. 0.63 grams of NaHCO3 will utilize 36.5 upon 84 into 0.63, which is equal to 0.2737 grams of HCl. Now we are given with molarity of HCl, which is equal to 1 by 10, and volume of HCl, which is equal to 150 ml. So we can find out the number of moles here. Moles upon volume is equal to molarity, but the volume should be in liters. So we get millimoles equals to the molarity into the volume in mLs. So we get 15 millimoles of HCl. So weight of HCl is equal to, this is 15 millimoles, hence 15 into 10 power 3 moles of HCl. And we know that the weight is obtained by multiplying the number of moles with the molecular weight of HCl, which is equal to 36.5. Hence we get 36.5 into 15 into 10 power 3 minus 3 to obtain the weight of HCl as 0.5475 grams. Hence the total weight of HCl utilized is equal to the amount of HCl utilized by Na2CO3 plus the amount of HCl utilized by NaHCO3. The amount of HCl utilized total is equal to 0.5475. This is equal to the amount of HCl utilized by NaHCO3, which is equal to 0.2737 plus the amount of HCl utilized by Na2CO3, which we calculated earlier as 75Y upon 106. On solving this equation, we get Y equals 0.3975. Y was our amount of Na2CO3 present in the given sample. So our percentage of Na2CO3 is 0.3975 upon the total weight of the sample, which was 1.5 in this case. Mind you, don't take the weight as 2 grams because here we changed the sample and took the weight as 1.5 grams into 100. On solving this, the percentage of Na2CO3 came out to be 26.5%. Now the percentage of NaHCO3 is 42%. Percentage of Na2CO3 is 26.5%. So the rest amount, which is Na2SO4, it is present in 31.5% amount. Hence the final percentages are 42% of NaHCO3, 26.5% of Na2CO3 and 31.5% of Na2SO4, which is our final answer.